Hi, Algebra 1. We are going to be looking at lesson 2 here called How Does It Change? And in this lesson, we're looking at patterns, visual patterns, and trying to figure out how they change. Here we go. So now you have these patterns drawn out, and you're probably realizing some things that are happening as you go from step to step. A couple things to notice here is that in pattern 1, we seem to be adding 2 dots onto each one of them. And when we're always adding the same thing at each step, this is going to remind us of all of those linear functions, linear patterns that we've been working on throughout most of the year. Pattern 2 is doing something very different. We're not adding the same number of dots each time. You may have thought about it as adding a row and another column with each step. That's one way to look at it. Another way to look at it is that we keep creating these squares, and the squares are the length of the step number. So for example, in step 3, our square was 3 by 3. In step 4, our square was 4 by 4. And in step 5, our square was 5 by 5. This is not going to be a linear pattern. It's not going to be an exponential pattern. This is going to be something that our new pattern that we look at called quadratic. And we're going to see what that looks like in equations coming up. These first 5 steps weren't too bad to fill in, but once we get to try to figure out the 10th step, now we need to figure out some sort of process. How can we do this? And looking at pattern 1, I notice that I'm starting out with 1 dot, right? And that 1 dot is there every step of the way. So I always have 1, and then I'm adding on 2 dots each time. So in step 1, I added on 1 group of 2 dots. In step 2, I added in 2 groups of 2 dots. In step 3, now we have 3 groups of 2 dots. And so I'm looking down here at n, which means we're going to write the equation to figure out how many dots are in any step number. And again, I'm noticing that I'm always starting out with that 1 dot, and then I'm adding on 2 dots, and how many times I'm adding on 2 dots is the same as the step number. Here I added in 2 groups of 2 dots in step 2. Here I added in 3 groups of 3 dots, or 2 dots in step 3. So this n is always referring to our step number, and you might want to label that. N is always referring to the step number that we're talking about. So going back here for step 10, I'm going to have 1 plus 2 times 10, meaning 10 groups of 2 dots I'm going to add on, and that's going to give me a total of 21 dots. In pattern 2, we talked about how we had been seeing squares with the side length of the step number. So this one was 3 by 3. So step 10, if I sketch that out, I would have a big square with side lengths 10 by 10. So it would be 10 times 10, which would get us 100. So all along the way here, I'm taking my step number n and I'm multiplying it by n to get us the number of dots in that square. We could also write that as n squared. So down here in our formula, you could write it either way. We are going to get used to writing this as n squared just because it's a more succinct way of writing it. When you graph them, you notice that in pattern 1, you end up with that nice straight line. Again, that's showing us that it is a linear function. And in pattern 2, we notice we end up with this curve, and it kind of looks like that exponential growth that we've seen in the last chapter, but notice that we do not have a common factor here. We don't have a common number that we're multiplying by each time down our pattern. So that means that it is not exponential, even though this part of the graph kind of looks like it. This is going to be what we call quadratic. And that's what we're seeing a lot in this unit, and that's because of the n squared that shows up in our formula. I've started my table over there on the right, but I'm going to think a little bit more about step 4 and step 5. When I look up at my pattern up here, I'm noticing that I see this square showing up in the middle, and then I'm always adding on these extra 2 squares there. And we see this here on step 1 as well. So step 4, I would have a square in the middle that's going to be a 4 by 4 square, and then I'm going to have these 2 squares off to the side. Step 5, I'm going to have a square in the middle. That's a 5 by 5 square. And then I'm going to have these extra 2 squares off to the side. So now you've completed the rest of this table. Step 10, again, you would have that square in the middle, 10 by 10 square, it's 100, and then you add 2. And then 12, you'd have that 12 by 12 square in the middle, which is 144, and then you would add 2 little squares. So our overall formula, what's happening here? Well, I'm seeing an n squared show up in that middle square in every step of my pattern. And then every time I'm adding on 2 extra squares. So n squared plus 2 is going to be the formula for this one. Is this growing exponentially? And we're going to have to say no, because we do not have a common factor here. I'm multiplying by 2 to go from 3 to 6, but then if I multiply by 2 again, I do not get 11. So we don't have a common factor, so it's not exponential growth. And that's because of the n squared term that is making it a quadratic function. In your lesson summary, you have this pattern along with this table. And again, we're just showing you how we come up with this n squared plus 1 rule for this pattern. Well, in this one, I see a square that is 3 by 3, which is my step number n, so n times n, which is n squared. And then I'm always adding in that 1 square right there every time. So I have a square, n times n, which is n squared, and then plus 1.